Hello engineers, welcome to a new video on low-level design. In this video, we're going to take up an interesting question about movie ticket booking. I hope you're ready. Let's get started. So this is the scope we're going to work with today. Design a system for a movie theater chain that allows customers to browse movies, select showtimes, and book tickets. The system should handle multiple theaters, each with multiple screens. Each screen can show different movies at different times throughout the day. Customers should be able to select seats from available seats for a particular show. The system needs to handle seat inventory, calculate ticket prices, and manage the booking process. Consider that customers can book multiple seats in a single transaction, and the selected seats should be temporarily blocked during the payment process. Right? So this is the scope we are going to work with today. So let's imagine how the situation will play out if I'm the user. So I log into a website or an app. I'm trying to select a movie and then I'm going to see where the movie is being played. I select one of the theaters and then at the theater there will be multiple show times at which this particular movie is playing. I'll select a time slot and I go into the theater's layout for viewing the available seats, and then I pick a seat or a bunch of seats and then I block those seats while I make a payment. Once I make a payment, I receive a confirmation along with my ticket. Right? So this is a simple movie ticket experience that we all have. So what do we need here? The first thing we need is this hierarchy of these chains of movie theaters, right? So there are theaters. So there are theaters which have multiple screens if it's a multiplex theater, right? And then within a screen, there can be multiple schedules. Per day, there will be different movies being played at different time slots, right? And the time slots can be dynamic in nature depending on the movie length or the time of the month or season and things like that, right? And then for each screen, there will be a fixed set of layout for seats. So there can be different types of seats. There can be economy seats, there can be normal seats, there can be sleeping chairs these days and so on, right? So there are a bunch of different types of seats. And after that, we need a mechanism to handle the state of each seat, whether it is booked or whether it is available per schedule. So for every movie that is being played, we need to allocate time and the seat availability for that movie. And for each seat, there can be a different pricing. So if it's an economy chair, the pricing would be different. If it's a recliner chair, the pricing would be different. And the pricing would also differ based on the time that the movie is playing. If it's an early morning show or a late night show, or if it's a new release, or if it's a pretty old movie for a re-release, there can be many such strategies for pricing a particular seat inside a screen, right? And then once we have all this booking mechanism, once the user selects a booking, we need to somehow block this seat so that other movie users cannot book the same seat while some other user is trying to make a payment, right? So this is a typical concurrency problem. So one user has already selected it and is in the process of making the payment. The payment can be successful or payment may not be successful. User can change their mind. There can be anything that can happen within this time. But until that decision has taken place, the seat needs to be blocked and should not be shown available to other users, right? And after that, the user will make a payment and then we need to issue something called a ticket, right? So the ticket will hold the movie time, the date, the seats, the transaction details and so on, right? So let's see the class diagram. So let's first start with a typical tree. So this is a theater. Theater has multiple screens and one screen has multiple schedules and also multiple seats, right? And what is inside a schedule? The schedule has the movie, the date, the start time of that particular movie, right? So for our example, let's assume that there are mechanisms in place to avoid overlapping of show times, right? So there's a movie object which has nothing but a title, date of release, cast, director, and so on. And who are these actors and directors? They are simple persons. So I kept it simple. So there's a simple person with a name and the person can be actor, director, or a user. So the schedule has a date, movie, and start time, right? And then we have seats. So what is a seat? Seat has a seat number and a seat type. So seat type can be a recliner or normal. So I've kept it as enum for simplicity. So this can also be extended to a different type of pattern if you need to, but for simplicity, I kept it as enum. So the seat types can be recliner or normal or any type of other chair, right? So the screens have schedule and also the seats. Now we'll come to the booking part. So for seat booking, we're going to combine the schedule with the seats. So for per schedule, the seats need to be in a particular state. So by default, all seats will be in available state and every seat will have a different pricing strategy, right? So that is what we will handle here. So imagine these to be number of objects per seat per schedule. So for each seat, there is a fixed schedule and a seat, and seat all internally has a seat number and a seat type. So there is a pricing strategy also included. So what is the pricing strategy? This is a typical strategy pattern where we have base price per seat, right? And this price can change depending on the type of strategy being used. If it's the regular pricing, there will be a fixed price. If it's a weekend pricing or a new release pricing and any other pricing strategy that can be applied to movies, which can be used here for that particular seat. And then seat will have a state, whether it's in available state or whether it's in a block state, temporarily blocked for payment process, or whether it is already booked, right? And if it's in temporarily blocked state, then we have an expiry time because we need to release the blocking after a certain point of time if the payment has failed or if the user has changed their mind and so on. And then we also have the user who will actually make the booking. So this seat booking will have everything that we need to know about for that particular movie, for that particular time slot, who is sitting in that seat, right? So we have all these details here. And then we will explore the methods for blocking a seat and booking a seat. Blocking a seat will temporarily block the seat and will create the expiry time. Booking a seat will actually take in the user and make the actual payment process and block the seat for that user, right? And then we have typical get state and get price. And this is the state pattern for seat booking. The seat will go into any one of these states: available state, block state, and book state. So we already know how to handle the state pattern by now. So when we say block seat, the seat state will be changed to block state. And then when we say book seat, then it will go into book state. And we also have the expiry time. So once this time is elapsed, we will need to put the seat back to the available state, right? So this is something we can handle using some kind of a background job, right? And then the final output for this entire booking process will be a ticket, which will have an ID, a movie name, start time, date, the bunch of seats for this ticket, and the user and the total amount, right? So the payment process is not included in this scope, but you can also expand this design for including the payment system as well, right? So this is the class diagram for a movie ticket booking system. Now let's see this in code. So I'm in VS Code now and we have a new repo for LLD movie ticket booking. So this will be a new repo and the link will be available in the description along with the UML diagram. So definitely check it out. So let's play this and see. So as you can see, booking successful for movie Inception. Total amount is $20, right? So let's try to understand this. Let me show you the important pieces. So to begin with, we are creating a new movie called Inception and we are creating a new user called John Doe, right? And then we have, let's say, 2 seats for that screen, A1 and A2, which is a normal and a recliner. And then we have a new schedule. So this movie will be played at 8 p.m. at this theater. And then let's say we can create 2 new seat bookings for seat 1 and seat 2, A1 and A2, right? For this schedule. So what happens here? So if booking 1.block seat, which means that we are trying to block a seat and that seat should not be blocked by someone else. So this will return a boolean. So if it is returning true, which means that we have successfully blocked that seat. And because we are taking in 2 bookings, so we are checking for 2 bookings at a time. And if we are going into this if statement, it means that both the seats have been successfully blocked, and then we can issue a new ticket for this particular user. And the seats will be added to the ticket, and this is the final amount, and we are just printing out the final amount, right? Very simple system. Now let's see the classes. So on the top, we have the enums for seat type and booking status. And then we have the movie class, which is holding the title, the date of release, the actors and the directors. Then we have the pricing strategy for regular pricing, weekend pricing. So we are taking in the base price and then we are calculating a new price. So we are just returning base price into 1.5 for the weekend pricing. Otherwise, we are directly returning it as it is, right? And then We have the seat class, which is just holding the seat number and the seat type. And then we have the seat booking class, which is holding a schedule, the seat, the pricing strategy, the booking status, the user, and lock expiry time, right? So this is where the locking is happening. So we have the block seat. If the current status is pending, then we change the status to confirmed, and then we start the locking expiry. So we are issuing a 10-minute lock for this particular seat. And then we use book seat. So we are changing the status to confirmed, and then we are returning true. And in the schedule class, we have the movie, the date, the start time, and the seat bookings. So this is an optional one. We don't need to manage seat bookings in the schedule class. We can keep it separate, but we can also do it this way. So that is up to you. And then we have the ticket class, which is holding the movie, the start time, the date, the seat, the user, and the total amount, right? So simple system. So let's see the different patterns that were used here. So first is the state pattern for managing the seat states. So the seats can be in one of these states, and we will change the state using one of the methods provided by the seat booking class. And then we have the strategy pattern, where we are dynamically managing the pricing strategy for each seat per schedule. And then we have the composite pattern here, where we are doing a nested tree structure. Theaters have screens, screens have schedules, and so on, right? And we can expand this to multiple chains. So a single vendor can have multiple screens across the city, multiple theaters across the city. So this can be expanded to one level higher as well, right? And then we can see the typical composition and the inheritance concepts here. When we are dealing with person can be extended to actor, director, and user. So these are different types of persons. So we can see inheritance as well here, right? So this is a good practice for low level design. So that's it for this video, guys. If you have any questions, definitely put them in the comment below. If you have any inputs for my videos, definitely put them in the comment below. Please leave a like if you found this helpful. Please subscribe to the channel so that you don't miss out on any other future videos. Thank you so much for watching. I will see you in the next one. Cheers.